Hello, we're ECOPIONE. Affordable and clean energy comes on number 7 of the 17 Sustainable Development Goals set by the UN. The goal is to ensure access to affordable, reliable, sustainable, and modern technology for all. However, there is still 1/10 of the world's population who cannot access energy. 675 million are still living in the dark, and 80% of them are in the sub-Saharan Africa where access to electricity is a privilege. To combat this, the solution we came up with is to use microbial fuel cells to create electricity with the use of soil to create compost, microbial bacteria to generate voltage. Why microbial fuel cells? Unlike fossil fuels, which take millions of years to form and running out, renewable energy sources are naturally replenished and worn out. Microbial fuel cells can use organic waste, preventing methane, which is a greenhouse gas, from being released into the atmosphere. They produce electricity without combustion, significantly reducing carbon dioxide emissions. They do not emit harmful air pollutants like sulfur oxides or nitrogen oxides, which contribute to acid rain and respiratory issues. Electricity is one of the most widely used forms of energy. However, in recent years, many countries in Africa have struggled to access electricity.
We set our focus on one of the countries in sub-Saharan Africa, Kenya. The drought in Kenya has been so severe early in 2020 and 2023 that the government has declared a national disaster. With food production dropping, which resulted in more than 2.6 million without access to food or electricity, mainly focusing on the capital, Nairobi, where one of the most biggest slums are located, called Kibera. One of the main issues in Kibera is the lack of electricity, which only 10% of the 1.3 million population actually have access to. Basic electricity to light the houses, which includes street lighting, security lighting, and connect to shacks, which cost 5.5 pounds or 900 Kenyan shillings per shack. Our aim is to use microbial fuel cells to provide electricity for these areas. Kenya's main source of electricity is hydropower with 70% and fossil fuels making up around 20%. However, the drought has now affected the energy production in the country, with the highest amount generated by hydropower being 4,386 million kilowatts hours in 2013.
Kenya's annual temperature has an average minimum of 9 to 12 degrees Celsius, with the average maximum being 25 to 28 degrees Celsius. Kenya average rainfall varies between the seasons, with 25 mm in January as the lowest average rainfall and 140 to 5 mm as the highest in April. However, with the drought, the numbers have changed drastically, but Kenya still has a minimal rainfall to keep the microbial fuel cells moist to generate electricity.
We started off by digging up sand and mud off the back of our skull that includes the microbial bacterial called Schwannella, which can be found in almost any soil on Earth. Then started to shift the sand we collected, removing big rocks and lumps to turn into compost. It is created by adding water to the sand and create mud that is left for a separate box to ferment. It's left to ferment for a week, and once it has fermented, then it's separated to different beakers with different sizes, 50 and 25 grams. The first experiment carried out includes electrodes, compost mixed with 80 cm³ distilled water with 25 grams of compost, with the salt bridge soaked in water connecting the two beakers of compost. The crocodile wires are linked to the electrodes, which is plugged into the voltmeter to measure the voltage output. The voltage is measured by submerging the two electrodes on each side of the beakers, and at the anode, the electrons travel down the wires and into the cathode, creating a potential difference which outputs as voltage in the voltmeter. The beakers are then left to ferment for a longer time in the sunlight or room temperature, with voltage increasing every 10 minutes by around 0.03 volts. Our final experiment has been conducted with copper sulfate instead of the two compost beakers to generate a higher voltage. The equipment used for this experiment are copper sulfate, distilled water, voltmeter, beakers, compost, electrodes, wires, salt bridge, and measuring cylinders. Measured 25 grams of compost and was mixed with 80 milligrams of distilled water and 100 grams of copper sulfate with a salt bridge in between them to allow electrons to flow. In this cell, it uses electrogenic soil bacteria, with the anode supplying it with a lot of electrons to flow to the other side to break down organic substrates in the compost. The more fermented it is to include more bacteria, the more voltage the microbial fuel cell will produce. We repeated the experiment with initial starting weight of compost to be 50 grams instead of 25. It has created more voltage, and with enough time to ferment on a large scale of compost and land, It will successfully create electricity to source an area.